This next video is going to talk about percent composition, but in order to do that, we need to review molar mass. Okay, so the molar mass is the mass of 1 mole of a substance, and we have those units of grams per mole, and they allow us to convert between grams to moles or from moles back to grams again, and we're going to need that here. So this molar mass is the atomic mass on the periodic table, and like we've already gone over, we round everything to 2 decimal places because our scales go out to the hundredths. Okay, so we need those 2 decimal places, except for hydrogen, he gets 3. All right, so this is something that you've already seen, but just want to go over it because we're going to need that heavily here. So carbon, 12.0107 on the periodic table. We round to 12.01. Those are our 2 places here. Oxygen, 15.99994, rounds up to 16 even. And hydrogen is the one that gets those 3 decimal places. And this 9 forces this to be 1.008. Okay, so those are the most common ones that we use all the time, so you're most likely going to memorize them. And don't forget, we have 3 different types of molar masses. So again, another review: gram atomic mass, gram molecular mass, and gram formula mass, which is your GAM, GMM, and GFM. So the GAM is the molar mass of the element. Anybody on the periodic table? Our molecules are our nonmetals to nonmetals and hydrogen, and then our formula units are your metals to nonmetals. Okay, so with all that being said, what we're looking at in our percent composition is basically the percent by mass of each element in our compound. All right, so this percent composition is actually one of the fundamental ways that we determined, or scientists determined, that there were atoms because they found that compounds had a specific percent composition. So the steps for figuring this out are going to extend off of finding the molar mass. So it helps if you show your work. So definitely make sure that you are showing your work here. So find how much each element weighs in the compound. So you're basically finding the molar mass. And then you're going to divide each element's subtotal by the total molar mass. And since it is a percent composition, we're going to turn that decimal into a percentage by multiplying by 100. And since this needs to add up to a whole, all of our percents should add up to 100% to show that you did it right. You're going to need a calculator, so please go get a calculator and push play when you have returned. All right, so here's our first example for percent composition. All right, so what is the percent composition of each element in water? Water is H2O. That means I have 2 hydrogens and I have 1 oxygen atom. Okay, so first we have to figure out the molar mass of water. So we look on the periodic table, hydrogen is 1.008, oxygen is 16. We multiply them together. We get 2.016 as my subtotal for hydrogen and 16 grams for oxygen. We add them together and we get a total molar mass of 18.016. So what is our percent of hydrogen going to be? Well, I have 2.016 grams of hydrogen out of my 18.016 grams of water total. And my percent of oxygen is going to look exactly the same, but for oxygen's value. I have 16 grams of oxygen out of my 18.016 grams of water total. And each one of these numbers I want to multiply by 100 so that I can turn them into a percent. Okay, so let's check out this next slide here. So here I'm going to plug into my calculator 2.016 divided by 18.016, and I'm going to multiply by 100, and I get 11.2% hydrogen. And then I get 16 divided by 18.016 times 100, and I get 88.8% oxygen. Okay, water will always be in these percentages, okay, in that specific breakdown. If I add these up, I get 100% of my water molecule. Okay, so this definite proportion is going to be exactly what we see for water. If my compound is not 11.2% hydrogen and 88.8% oxygen, it's not water. So that means you have some other hydrogen-oxygen compound, which could be like hydrogen peroxide, which is H2O2 and would be in a different percent by weight. Okay? Let's try another example, something a little bit more complex. Oh, hey, look, there it checks out. Okay, so my next example is what is the percent composition of each element in aluminum sulfate? So one of the things that you're going to see is we're going to start making these a little bit more challenging. Aluminum sulfate is Al3 plus and SO4 2 minus. So you might have to figure out the formula first. So that means we are going to crisscross my 3 plus and my 2 minus. Crisscross makes you wanna bond, bond. So we have Al2, SO4 taken 3 times. And you need to do the atomic inventory that we have been doing every time we do our molar masses by saying we have 2 aluminums, we have 3 sulfurs, and we have 12 oxygens. You look up each one on the periodic table. 26.98 for aluminum, 3207, notice we have our 2 decimal places, and 16 even for oxygen. And then we multiply across. If we add all of those up, we get 342.17 grams of those. So if I want my percent of aluminum, I have to take my 53.96 grams of just aluminum out of my 342.17 grams total. And if I want my percent of sulfur, it's going to be 96.21 grams of sulfur out of my 342.17 grams total. And my percent of oxygen is going to be this subtotal, not the 16. It's the 192.00 grams of total oxygen out of the 342.1 grams total. And then each one gets multiplied by 100. So you have your calculators ready? Okay. Try them out. See what you get. Okay? Push pause, write them down, and then you'll check. Okay, ready to check your answers? The first one is going to be 15.8% aluminum. I would round to 1 decimal place. It just makes it a lot easier than trying to do 2 decimal places. So you don't get into that whole 99.9999 or 100.001 issue. Okay, for sulfur, we are at 28.1% sulfur. And for oxygen, we are 56.1% oxygen. So all of them add up to 100%. Yippee! Were you right? Did you do it good? Good. Okay, if you didn't, some of the things that you can be stuck on is you didn't divide by all of the aluminums. We have 2 aluminums here, or all of the sulfurs, which there are 3 of them, or all of the oxygens. Sometimes it's rounding error. So if you need to go back and watch the video on rounding, make sure you do that too. But that is percent composition.